Hello, everyone. Welcome to today's webinar. Thank you so much for joining us today. We're going to be getting started in just a moment, but before we get started, I'd love to tell you about some upcoming webinars. Next Wednesday, February 28th, we'll have a presentation on work stressors and illness in the United States, the Healthy Work Campaign with Dr. Peter Schnall and the California Labor Lab. And next Tuesday, March 12th, we'll have an industrial hygiene approach to assessing transit operator exposures to fentanyl and methamphetamine with Marissa Barker, PhD, in the Northwest Center for Occupational Health and Safety at the University of Washington. Our next ergonomics webinar will be on Wednesday, March 20th with Danya Kidal, MD, MPH, and the University of Cincinnati Education and Research Center. So we'll be joined with the University of Cincinnati once again. Thank you. For more, you can visit us online at coeh@berkeley.edu/about-CE. And on behalf of education and research centers throughout the country, it is my pleasure to present the Human Factors in Ergonomics webinar series. This is a collaborative effort on behalf of each education and research center continuing education program and aspires to provide access to current research supported through NIOSH ERC programs. We appreciate you all joining us today. Today's webinar, Evaluating Firefighters' Hypothermia Level with CNT-based cooling system during live burn firefighting, is brought to you by the University of Cincinnati Education and Research Center and Dr. Amit Bhattacharya. A few housekeeping items first. You are going to be muted during this presentation. If you'd like to ask a question, please enter it into the online Q&A, and we'll save time at the end of the presentation to address as many questions as possible. This presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page within 5 business days. And last but not least, all participants who logged in today with their full registration email for the full live presentation will receive an email tomorrow with a link to an evaluation form that will qualify you for a certificate of completion worth 1 continuing education contact hour. Once the evaluation is completed, you'll be able to access and print your certificates. Without further ado, it is my pleasure to welcome our presenter for today, Dr. Amit Bhattacharya. Dr. Bhattacharya holds a PhD in biomedical mechanical engineering and an MS in fluid mechanics and heat transfer, both from the University of Kentucky in Lexington, Kentucky. He is director of the Cincinnati Education Research Center Training Grant and the founding director of the EDDI Lab, which stands for Early Detection of Degenerative Disorders and Innovative Solutions, housed in the Department of Environmental and Public Health Sciences. He is also the founding director of the Pilot Research Training Program sponsored by the National Institute for Occupational Safety and Health, or NIOSH. His research interests include gene-environment interaction and its impact on human neuromuscular system, and the application of nanosensor technology for early detection of neurodegenerative and degenerative skeletal disorders. Thank you so much for joining us today. We're really looking forward to your presentation.
Should I start now?
Yes, go ahead. Take it away. Thank you.
Great. Thank you, Michelle. I appreciate the opportunity to give a presentation. Welcome everybody who's joined here. My title of my presentation is Evaluating Firefighters' Hyperthermia Level with CNT. CNT stands for Carbon Nanotube-based cooling system during live burn firefighting. Preliminary findings. The reason I say preliminary, because the project is still active and there are a lot of changes going on. This project is a collaborative study in collaboration with University of Cincinnati's Colleges of Medicine, Engineering, and Design Arts, Architecture, Arts, and Planning, and NIOSH Pittsburgh Lab. It is funded by Ohio Workers Safety Innovation Grant, Bureau of Worker Compensation Agency. It is carried out by several team members, and they are either faculty or graduate students. This slide's actually going to give a knowledge of what we have learned from firefighters exposure to heat since year 2001, because I've been studying firefighters since 2001, so I thought I'll share that first. So we have been collecting physiological data such as real-time heart rate, real-time core body temperature, and real-time changes in the hypothermia. I'll define hypothermia in very soon. So during firefighting, core body temperature continues to rise above hypothermia. Hypothermia is defined by when core body temperature reaches 38 degrees centigrade or 100.4 degrees Fahrenheit. Firefighters experience core body temperature levels above the hypothermia limit while fighting fire. Firefighters experience above hypothermia limit even after they finish firefighting. And we have data collected in the firefighters in our project where we found that even after they stop firefighting, their core body temperature continues to rise for next 8 hours. On average, 100 on-duty firefighter deaths occur every year in the United States. 45% of these deaths are cardiovascular related and are a major cause of morbidity. The magnitude of risk for firefighters are at high risk of sudden cardiac arrest, and one contributor is the extreme cardiovascular strain due to the work demands and heat stress. So the firefighters are at a risk of dying on the job from preventable cardiovascular condition. The preventable I mention here because we know it is preventable. The problem is we have not done enough to develop technology to identify the hypothermia level before the firefighter core temperature reaches that level. And that is the reason my laboratory and my colleagues have developed some early detection technology. The firefighters' fatalities are work-related. Over 75% of firefighters' deaths occur while traveling to or from an incident, at an incident, or during training activities. So it's pretty much, unfortunately, depends upon their exposure to firefighting. In addition to the firefighting, we have to learn about the type of jobs these firefighters are doing. Their job requires them to work in a shift work. I'm sure you all know about shift work. The firefighters usually work 24-hour work, then 48-hour off. And even though they're only working 24-hour, the 48-hour off is not enough rest period for them to recover. So the data shows in the literature that their blood pressures are very high. They are unfortunately have high heart disease. They are always fatigued. They are exposed to errors and injuries. And they also have a serious problem of sleep disorder. Sleep disorder such as sleep apnea. Now, some of you may know what sleep apnea is. Sleep apnea causes the person to stop breathing while they are sleeping momentarily, and sometimes it kills them. In a recent conference, I was there where a lot of firefighters were listening to the seminar I was giving. And when I asked them, how many of you have sleep apnea? Literally 80% of the audience, the firefighter, they raised their hand. They were suffering with the sleep apnea. I've been to the firefighters' fire station. I've been to their sleeping quarters. Every sleeping quarter I visited, majority of the time, next to their bed is sleep apnea device. So they cannot sleep without that machine. Also, the data from our laboratory and other people have shown firefighters have a very poor postural stability, meaning they have problem in the standing and walking. They have a tendency of losing balance and fall. Another thing which I'd like to share with you is that, as you know, the firefighters are exposed to a variety of toxic environment when they're fighting fire. One of them is the most dangerous toxin called phosgene. Phosgene is a chemical which, if you are exposed to it, you won't have any problem. But a day later, you will wake up with a pulmonary edema, meaning the water is collected in your lungs and kill the person. So it has a very serious consequences. So having given a little bit of background about firefighter research, there is a gap in research. The firefighter coats, the turnout coats, do not have any protection to allow the core body temperature to be reduced. In other words, when they go out in a firefighting environment, their coat is not designed to protect them from causing their core body temperature to not go above hypothermia. Therefore, our research team at the University of Cincinnati has developed an active textile, in short, AT system, integrated into firefighter turnout gear and personal protective equipment. This AT coat has coolants embedded inside carbon nanotube-based fabric, which minimizes increase in core body temperature. So most of the fire code, not about 100% of the fire codes are not designed to protect the firefighters to have a core body temperature below the hypothermia level. So I'm going to explain this in the next few slides. For core body temperature measurement, there are two types of sensors we use. First one is the FDA-approved ingestible radio pill. You see a little pill right here. It's very small. And they actually swallowed it during our research project. And it goes into the small intestine, and that's where it records the core body temperature, and that is transmitted wirelessly to a recorder. A newer technology which has come about is known as wearable bioharnesses right here. This does not require swallowing this sensor. It can be attached to the chest, and it will continuously monitor the firefighter's core body temperature, heart rate, and also firefighters' body motion in 3 dimension, and also measures ECG. So this is the radio pill, ingestible radio pill here. You see right here, it went down into the stomach, small intestine, not stomach, small intestine, and from there it transmits the core body temperature received by the receiver, which is held in the pocket of the firefighter. This is the bioharness, wearable inertial link sensor bioharness. It quantifies core body temperature, postural balance, heart rate, ECG, as well as breathing rate. So that gives us a totally non-invasive sensor technology, because the ingestible one is not totally non-invasive because you have to swallow a tablet, a pill. Okay, this is a brief description of the active textile AT system integrated into firefighter turnout gear. So the picture you're seeing here on the right-hand side, this is the photograph of a regular coat, but inside the regular coat, we have put in carbon nanotube fabric, and that fabric fits the body of the firefighter such a way so when a firefighter was warned that there are ways we can cool his body by using specially designed pouches right here, one on the left, one on the right. I think there is a third one too being made right now. And there are micro fans, very small fan embedded in the pouches. And these pouches also hold dry ice. That's where the cold air can be generated. And with this blue tube you're seeing, they are connecting to the pouches, and it takes the cold air and distributes around the entire body. So that helps reduce the core body temperature. So carbon nanotube are also thermally anisotropic. Now, anisotropic, it means they easily conduct heat along the axis of the individual tubes and are relatively insulated across the tube's diameter. And this is the ideal way the firefighters can be protected from heat coming inside the body. At the same time, it allows them to dissipate metabolic heat, which causes sweating, to dissipate the heat to leave the body out. So that made it very, very practical. And we have carried out several simulation studies to show that under heat stress condition, firefighter skin temperature was considerably reduced by the cooling layer. So each firefighter tested during live firefighting wearing two coats. One is the regular coat they're wearing without a coolant. Other one is the cool coat with the coolant. This is the location of live firefighting, live burn firefighting facility near University of Cincinnati, about 20 minutes drive. These buildings are designed to create live fire, where they train firefighters to fight fire and get experience in doing this type of job. I'm gonna place this thing to show you, and you can hear it, that how noisy this event is. Going into the building, suppress the fire. Go to 3 levels, 3 floor facility. So here, this is a schematic of the live burn protocol. So here it shows the baseline, meaning they are not into the live burn building yet. So at the baseline level, we do a variety of measurements, and some of those measurements I will discuss in the next few slides. And when they come out of the baseline to go into the live scenario, this is where they're inside the burning building and they're fighting fire. And that's last about 15 minutes. And then they get out of here, some measurements are made again, and the rest period is about 15 minutes, and they go back to the live burn scenario, fighting fire, and so forth, all the way to 3 scenarios. This entire duration of live burn protocol is about an hour. And the studies which I have done over the years, we got data showing after they are done with 3 scenario of firefighting, and they were, those times they were using the radio pill. They were gone home, and since it's a radio pill, I can monitor their core body temperature even they are gone home remotely. I could see their heart rate, their core body temperature was still above the hyperthermia level and was as high as 102 degrees Fahrenheit, the core temperature. That's bad. That's dangerous. That can kill them. Okay. Anyway, this is a schematic of the live burn fire training monitoring subjective measures. Subjective measures were perception, which is the symptoms firefighter can feel, and those perception tools are thermal comfort, respiratory distress, and Borg physical exertion. So these are measured during baseline. These are measured right after scenario 1, measured right here, and then right after they finish scenario 2, during rest period, and then during the last scenario 3. So these are the subjective measures, which is a questionnaire base, and I'll show you in the next slide how we do that. We also measure during live burn training objective measures such as core body temperature, heart rate, and heart rate variability, which is a useful measure of autonomic nervous system. So here, during baseline, we measured all the objective measures of measures. Then we measured, and we can measure these heart rate, core body temperature, and HRV continuously while they're fighting live fire. So it goes through the whole scenario 3 and we get the objective measure. Okay, this is the measured subjective measures. And using the following metrics, we captured subjective perception of thermal comfort, which has a scale from 0 to 8. So 0 meaning unbearably cold, and 8 meaning unbearably hot. So somewhere in between, there is a comfortable area. So we ideally want to make sure the firefighters are feeling comfortable. The other tool we use for perceived respiratory distress, which is right here, and scale is between 1 and 7. 1 being my breathing is okay right now, 7 being they can't breathe. So anyway, somewhere in between is what we want the firefighter to be. The last one is Borg physical exertion, which refers to subjective feeling of physical exertion the firefighters are doing while fighting fire. And that ranges between 6 and 20, 6 being very comfortable, not stressful at all, and 20 meaning it's a very, very hard physically. So this is the statistical results from a small sample of firefighters. The thermal comfort, see the regular coat or standard coat and the cool coats differ significantly on thermal comfort overall. And the cool coat is ideally comfortable, but not the standard coat at the baseline level that was statistically significant. On average, the CS coat is closer to the comfortable level than the SF coat in scenario 3. So realize these statistics doesn't mean anything at this point because sample size is small. We are still going to be collecting more data in the future. These are the results from the respiratory distress. And the comments here are the SF code and CS code differed significantly on respiratory distress scale overall. Breathing is okay with CS code and SF codes at the baseline. On average, it is less stressful with CS code than with SF code. Now, these are some findings we're going to present after this slide. The heat storage objective measures, heat storage, because when they're exposed to firefighting environment, the body actually absorbs the heat and keeps it in the body, and the brain is not able to dissipate that heat storage, and that can cause hyperthermia. It can also measure the heart rate changes, and the hyperthermia is measured by using either radio pill or bioharness sensor on the chest. So hypothermia, you have to make sure the firefighters' core temperature is not above 38 degrees centigrade. This is comparing the core body temperature by two codes. And this graph here shows on the y-axis the core body temperature, and x-axis is the events in the live burn, the baseline, scenario 1 in the fighter live burn, then resting period 1, and so forth. And this is the horizontal line you're seeing is the hypothermia threshold. So what you're seeing is the CBT, which is core body temperature during baseline in scenario 1 was below hypothermia level for both regular code and the cooling code. So right here, you can see it. These are below the hypothermia level. And then it starts to go up. Now, the heat actually builds up slowly. It doesn't suddenly change. It slowly builds up. So as the firefighting is going on, scenario 1, then scenario 2, and scenario 3, it continues to slowly rise and goes above the threshold of hypothermia. And that's where the need of intervention is very important. And that is what our team is working on it right now. So in summarizing the core body temperature and heart rate over time with the regular code, the core body temperature remains below 38 degrees centigrade during the baseline and scenario 1. Remember, the baseline means before they enter the live burn facility. The average temperature remains above 38 degrees centigrade persistently after scenario 1. The heart rate is exhibiting an expected pattern, high during the scenarios and low during the rest period. Now, this is an important comment because it is a natural and expected that when you are working in a hot environment, your heart rate will go up. You can't change that. But when you take a rest, you expect the heart rate to come back to the resting level, but it did not come back for firefighters. Because if your heart rate is not come back to the baseline, that means your body is fatiguing. So fatigue is what you have to avoid, especially firefighters. So during live burn, this is the summary of the cool code. Core body temperature remained below 38 degrees centigrade during the baseline and scenario 1. The average temperature remained above 38 degrees centigrade persistently after scenario 1. The heart rate is exhibiting an expected pattern, high during the scenarios and low during the rest period. So compared to core body temperature, the heart rate measurement is equally important. And a lot of researchers many years ago have published that the firefighters' resting heart rate is not coming down to a lower level. So if it doesn't come down to lower level, that is a sign of the physical fatigue building in. So conclusion in general, the cool code is better than standard code with respect to thermal comfort measure and the respiratory distress. In the future, we will be modifying the cooling system to further enhance the active textile system's cooling capacity. Thank you very much. I'm open for any comments or questions.
Excellent. Thank you so much for sharing this information with us, sharing your research. And at this time, to our learners, please go ahead and enter any questions that you might have into the Q&A box. If you could do me a favor and put them in the Q&A rather than the chat, that is much appreciated. All right, so we're going to go ahead and jump right into our first question. Has anyone considered a 12-hour shift with 24 hours off for firefighters to address some of these hazards? Or better yet, 12 hours on and 12 hours off? Would changing the shift schedule help?
It's a good question. Our team has addressed this issue almost 10 years ago because my close friend and colleague is a fire chief who also has a PhD in fire science, Dr. B.J. Yetter. And he and I were able to take our live burn project data and took it to his administrators and convinced them to change the shift. They went actually 24, let's see, 24-hour work, then 72-hour off. So he says that the fatigue is so much, 48-hour working is not as resting is not enough. You need a longer. And that is something very important to appreciate because these firefighters are really risking everything, not just body, their mind, everything. So they need a lot more time off. And, I've been to firefighters events where I met their spouses, and their spouses actually told me that the firefighter, when they come back from work, shift work and fighting fire, they have absolutely no idea what the heck is going on in the house or in the world. They cannot get up on time, cannot play with the children, nothing. So you need to have a lot more feasibility to give them more off time.
Thank you so much. What effect, if any, do epigenetics have on body temperature? Do firefighters living in or from hotter climates manage body temperatures more efficiently?
Good question, but we haven't had a chance to carry that out. We have done epigenetic studies in military people. I had an Air Force grant in there. We actually looked at epigenetic issues which causes problems with their neuromuscular system. By that, I mean their ability to stand upright and don't fall. And that was an Air Force study, and I participated in that one and got the data. And certain genetic biomarkers cause the neuromuscular system to be messed up, particularly the gene GST-mu, which is deleted in 40% of the US population. They're born like that. There's nothing you can do about it. They actually have poor balance. And I was part of a double-blind study.
Thank you. We have lots of questions, so thank you to everyone in our audience for all of the questions. We have plenty of time, so I think we should be able to get to them all. Is the AT cooling coat designed to be an insert into an existing turnout coat, or would it be integrated into a new coat?
It's going to be an insert, but we're working with the coat manufacturing company in Dayton, Lion Apparel. They've been in building of the coats since the late 1800s, and they are interested in actually design the whole thing, but it still be a layer which you can remove it if you don't want to have it all the time.
Thank you. Was sleep apnea detected in firefighters only when they were working, or has there been evidence of sleep apnea in retired firefighters as well?
Good question. I only know from the active firefighters. We haven't had a chance to recruit retired firefighters, but the people who have sleep apnea, I am not familiar whether they have recovered. Once they have it, they have it.
Thank you. Have you seen any therapies to reduce core body temperature? On the opposite end, the US Coast Guard gave someone's crew warm air to inhale after his core body temperature was hypothermic.
No, I'm not familiar with that particular study. Um, in terms of intervention, I guess you mean intervention meaning actually inhaling something. So, so in the study you're referring to, did they um, breathe in hot air or cold air? I didn't catch that.
In this case, it looks like they had breathed in warm air
Warm
after
air.
the core body temperature was hypothermic.
No, I'm talking about hyperthermia, by the way, not hypothermia. Hypothermia means the core temperature is low. Firefighters don't have that problem. They're fighting fire, their body temperature goes up, so they get hyperthermia. So
Thank
if
you.
anything, they should be breathing in cold air or cold water.
Thank you. Do you look at age, conditioning, cognitive, behavioral, and memory disorders, or any other psychological factors in your assessment of firefighters?
Yes, we look into a variety of cofactors, age, BMI, and the cognitive function. Not in this particular study, but another firefighter study we did. In that one, we did.
Thank you. Some fire departments are going into 48/72 hour shifts. Do you have an idea of how this might affect the firefighters?
Well, if they make them work 48 hours and give them 72, that's the protocol has to be investigated with a research project. No, we do not have money to do additional project. It's very expensive, but it's worth doing it.
Yeah, absolutely. Well, and actually, this brings up some of the other questions I'm seeing in the chat around cost as a limiting factor. For example, if firefighter uniforms are controlled at the municipal budget level, how is this cooling technology being communicated to decision makers around budgeting? Is this something that will be budgetarily feasible for folks?
No, absolutely. I agree with that. The actual codes cost, the one we have developed, is not finalized yet. Okay, it's a prototype. So once the prototype code is completed and tested, then we will look into how cost can be addressed. And that's why we're working with this company who makes fire code. So they are interested in making a better fire code with a cooling system at a reasonable price. So that's gonna come out maybe in the future.
Thank you. Couple more questions here. Thank you again to our audience for all of these great questions. First, a comment and insightful presentation. Thank you. Has your team extended this research, or do you plan to extend this research to wildland firefighter turnout gear?
Yes, we like to. We don't know where to get the money. I mean, you know, one of the persons who's working in the wildland firefighting in West Coast is a graduate of our occupational medicine residency program in my department. But we haven't got any funding to do it here.
Thank you. Yes, funding is a big issue in research. So if anyone has good firefighting research funding ideas, it looks like there's a lot of additional research that could be done on this topic.
Yes.
What are some of the long-term effects of such stresses on the body and central nervous system over a longer period of time?
Very good question. We actually have done a pilot study 5 years ago to investigate the relationship of being a firefighter for X numbers of years, doing firefighting, doing EMS run, and exposed to hot environment in the lifetime. We did an MRI study, and we found part of the brain was supposed to control the temperature in the body is messed up. So that kind of information we have. My graduate student actually have presented that in a conference last year.
Thank you. Are there any differences in heat tolerance among female firefighters versus male firefighters that you've been able to study or identify?
Would like to, but unfortunately, only 1% of firefighting population are female. So you're not going to get a big population to study because female body obviously is different than a male, and there is a need to investigate that. In my project, not the current one, the one in the past, I only studied in a project with only three female firefighters. Rest of them are all male. But I expect this to be a different results.
Thank you for sharing. Another question, are there any pilot programs currently that would provide this type of technology without cost to firefighter crews from various geographical locations for the purposes of research? Sounds like somebody wants to get their hands on some of this technology and help with the research.
Well, if you can help find the funding for it, I'll be happy to work with you.
Great, thank you. Has there been any research done on post-firefighting interventions to cool CBT, such as cooling vests, cold spaces, water, etc.?
I'm not familiar with it. The cooling vest type of research has been done, including one of my PhD students who published it in the last 5 years, several papers of the role of cooling vest. The problem with the cooling vest is that those are not self-sustainable, meaning it doesn't have cooling to persist very long. It just cools the body temporarily, maybe for an hour, and then it doesn't. So it's hard to really implement that in a job where the job is so urgent.
Great, thank you. That's a very good point. Is there any data available on firefighting serving on nuke sub-operations with the US Navy, specifically around steam generation and CBT?
Not that I know of.
Thank you. Did you take into consideration rest period protected from heat, radiation, or sun, or in climatized environments?
That's a very good point. We actually have published one article in 2013 where we brought in two groups of firefighters going through live firefighting training session, similar to one we presented today. And they had one fire department with a different rest period. Other firefight department was in a different rest period. So we saw the fire department which had a longer rest period, their core body temperature and heart rate were much lower. But it was a very small sample size.
Thank you. Thank you again, everyone, for all of these great questions. We still have even more, so great job in keeping our questions going. And thank you, Dr. Bhattacharya, for all of the answers you're giving us here. What area of the brain is managing heat regulation, and what exactly happens to it? Did it shrink? Does it lower the processing speed?
Hypothalamus. Hypothalamus in the brain, which controls heat and cold. Hypothalamus is a very small part of the brain The front end of the hypothalamus controls heat. The back side of that organ controls cold temperature. Now, acclimatization plays a huge role because if you are acclimatized to hot environment, obviously your body will be more conditioned to fight fire and not get hypothermia. That has been shown by many people. Hypothermia, the acclimatization of heat makes the body more attuned to fight hot environment because the body is used to being hot. It's like somebody who grew up in a very hot climate. When they go to any other hot places, if the new hot place is not that hot, they will have no problem, you know. So the human body can acclimatize in a hot environment very easily. Now, acclimatization of hot environment has a different role when humans go into space. I used to work for NASA, and there we actually caused the astronaut to go through heat acclimatization because when body acclimatizes heat, it actually causes a larger plasma volume, which is very important in a space flight. When you are in the space for a prolonged period, even if as short as 7 days, you lose a lot of blood volume. So when you come back to Earth, you lose your balance. You cannot stand upright. Your your blood pressure goes down. But if you increase the amount of blood volume by acclimatization, you have a more blood volume and plasma volume available. So acclimatization is important to keep in consideration.
Thank you so much for sharing that. That actually ties into another one of our questions. Could your research share interest in a broader need for smart technology fabrics specific to temperature that may be used for future space travel as a way to expand funding opportunities specific to your
That's a
team?
good observation, and hoping the team who is working with me on designing this new carbon nanotube based fabric, and that has many unique properties which needs to be explored for better solution of different types of problems. Yeah, in a space flight, and they have a humongous amount of problems, obviously, and being in that kind of environment, so carbon nanotube fabric may have some role.
Yes, thank you. Another environment that was brought up is there a relationship between work performed by firefighters and warfighters in combat scenarios? I understand that might be a little bit outside the scope of your research, but another situation to consider.
I mean, firefighting versus
Um,
actual battle.
yeah, in
Military.
combat scenarios.
Yeah, well, the combat scenario could be anything. At least in a firefighter, they know the scenario. They're not, 100% familiar, but they know how to fight fire. But when they are in a combat situation, you are in enemy ground. You don't know what they're gonna be. I mean, they are, of course, exposed to heat, cold, and also psychological problem in a combat situation. And even in the firefighters, if their health is going downhill because of exposure to firefighting, they also have a mental problem.
Very important considerations. What about hypothermic medications as an additive? Have you looked into the hypothermic medications in addition to the
No,
antibiotics?
because hypothermic medicine is more for people who feel cold. Their core body temperature is very low, so that may not be relevant for firefighters.
Thank you. And how much air is used by minute for the coat, and how does that impact the autonomy of the coat?
I'm sorry, what was the question again?
How much air is used by minute for the coat, and how does that impact the autonomy?
How much air?
Air, yes.
I mean, we're not using any air.
Thank you for that
It's
clarification.
a, it's a, it's a carbon nanotube fabric, and it's like a vest. They design a vest made with carbon nanotube fabric, and that is embedded inside the regular fire coat. So there is no air here. Maybe I'm not catching the question, better.
Oh, no, thank you for the clarification. I appreciate it. We have some more questions. What comorbidities have been the most problematic?
Okay, as a firefighters, if they have to fight fire as a firefighters, they should not have any health problems. They come in with a obesity, that's a comorbidity. If they come up with some other heart condition, that's a comorbidity. The good thing is that firefighters go through screening before they are admitted, and they catch those things when they are tested for all these comorbidities. So there is a standard procedure firefighter undergo, and based on the results, a firefighter may not or may be accepted and get the job. You know, they get all a stress test too on a treadmill, so they make sure that they have the capability. But you have to realize once they get the firefighting job, if they misuse the body, meaning they are eating a lot of food which is garbage, they will be stopped from working. You know,
Thank you. Some additional questions around volunteer firefighters and also hazmat firefighters. Are these populations that have been included in your study?
no, we have included volunteer, but not the hazmat.
Thank you. What about looking at cooling in the head and neck area? Is that something that you see possibility with your research?
That's a very good question. Actually, my colleague has developed head cooling device. Why head cooling is important? The research done by many people have shown the brain temperature is higher than the core body temperature. So brain is always at a higher temperature, and that means it is causing mental and central, they call central fatigue. Central fatigue meaning the tissues in the brain are getting all um, exposed to higher temperatures. The temperature difference between the brain and the core body is about 0.5 degrees. And that's even after core temperature is down, brain doesn't dissipate heat easily because brain size of the brain is much smaller than the torso, this is where the core body temperature is. So it doesn't have a natural way for the brain to dissipate the heat. Core body temperature does. So the publication by several people have shown brain temperature needs to be reduced, or cooling has to be done at the brain level before you worry about core temperature.
Thank you. Absolutely. A couple of notes looking at recommendations, looking into partnerships with the advanced textile community in Charlotte and Hickory, North Carolina. I guess they have
Yeah.
a very big textile industry there.
Yes.
And then also partnering with various universities and philanthropic foundations to explore funding and fiscal pathways for continuing this really important research. Another question, what is or are the working liquids used in the CNT PPE, and what is the sink for the heat rejection from the fluid?
Well, that's the CNT fabric which we are using is a patent. So my colleague from engineering who developed the CNT material, they said, please don't talk about all the details. So maybe once it is all cleared up, it will be available publicly.
Fair enough. Thank you. Thank you. Do the forever firefighting suppression chemicals have any hypothermic impacts on firefighters that you're aware of?
I'm not aware of it, but I'm sure there are available. I mean, you probably have to do the literature search to find it. I'm not.
Thank you. And how long are radio pills effective once they're swallowed? What is the window for them to transmit from the small intestine?
72 hours. You can just flush it down the toilet. But that nowadays, you can flush it down the toilet. I use the ingestible radio pill in mid-70s when I was working at NASA. And it was costing that little tablet $2,000 a piece. So that has to be retrieved and sanitized and reused. So luckily you don't have to do it because the new pills only cost $30 a piece. So we flush it down the toilet.
Wow, that is quite a big difference.
Yeah.
Sure, a helpful difference when doing this kind of research.
Yeah.
Thank you. Another question is, are there any links to any websites where they could look at this research or any more information about the cooling coat or technology that's under development? Are there resources you can share with the audience?
Well, I can find out links to some of these publications and I can send that to you, Michelle, if you want to pass it on. I don't know how to reach the audience.
Yes, that would be great. And to our listeners, what I can do is once I receive those links, I'll update the website where you all registered. So that'll be updated with both the recording from today's session and also the links that are provided to me so that you can
Yeah.
click around and learn more. Just
Right.
revisit that same website where you registered today.
So on that links, Michelle, I'm more than happy if you want to put my labs link. That has a lot of papers.
Perfect. Absolutely.
You can they can download a lot of papers from my website.
Excellent. Thank you. And we have one more. It's a pretty specific question. So, did you measure the difference of heart rate between the baseline and at the 4th minute of rest time, which refers to the extracardiac pulsation from heat nature by letting the HR from activity to come down? A reference to Malcher. If so, could you share to see the difference between the heat capture and EPCT?
Heat capture at where?
The difference between heat capture and EPCT, one EPCT is supposed to correspond to a rise in 0.25 degrees Celsius of the central body
Okay.
temperature.
We have the data, but we have not looked at it yet in the way you are referring to. But I think it'd be very important to look at it. See, heart rate recovery is very important because that is a measure of fatigue buildup in the body because of you working in a hot environment. And if you don't do that, then you have no idea how changes in core body temperature is impacting the changes in the heart rate.
Excellent. Well, again, thank you so much for your time today. Thank you to all of our learners today for the abundance of really great questions. Thank you, Dr. Bhattacharya, for joining us today and sharing your research. I'm looking forward to making those resources available and sharing the link to your research center with everyone today. So please make sure to our learners, check back on the website to see the recording. It'll be available within 5 business days. And we'll also update to share some resources and links to some of those research reference articles as well. Thank you all so much for joining us, and thank you
Thank
so
you
much,
all.
Dr. Bhattacharya.
Thank you, Michelle. Appreciate it. Bye-bye.
All right, have a wonderful day, everyone. Bye bye.
Bye.